What'd you get for number 7? The quadratic formula. All right, mathletes, so let's talk about it. We're going to be looking at the quadratic formula today. Probably one of the most popular formulas you see out there. And your teacher's probably making you sing the quadratic formula song right now.
Negative b plus or minus the square root of b squared minus 4ac over 2a.
All right, so let's talk about it, because a lot of people, they've seen it, but they don't understand when to use it and some shortcuts that I'm gonna save you a bunch of time with today. All right, because again, even though people know how to use it, often they work way too hard, and I want to help you out today. All right, so check this out. So first things first, whenever we have a quadratic equation, right, it's equal to something, and we have a quadratic, the square is our biggest exponent, and we're trying to solve for some variable, in this case x, we could use this quadratic formula to help us do so. And for me personally, I rather factor, but you can't always factor, right? So the good thing is this quadratic formula will always help us solve quadratics, all right? Quadratic equations. And what we're doing when we use the formula, we're looking for, really, if we're looking at the graph, we're looking at our x-intercepts, right? And there's a few things that could happen. So the first thing that we see happen often is we see our graph with 2 x-intercepts. And this quadratic formula is going to help us find those x-intercepts. Or we might have a graph, a parabola here, that might only have 1 x-intercept. And so we would see our quadratic equation lead to one answer. And what that means is whatever's in here, whatever is inside of our radical here, and this has a name, a discriminant, we'll get into that later, this is going to be 0.
Oh no!
Oh no!
Oh yeah!
And we'll see how that plays out, all right? And the last thing we might see, right, when we're using the quadratic formula, is we might not see any answers at all. And what that's going to tell us, no real answers. And what that's going to tell us is that we don't have an x-intercept, right? Our parabola here never crosses the x-axis. All right, so this is what it shows us. So make sure you understand not only how to use it, but what it actually means. All right, so let's dive in here and let me save you some time. All right, so in whatever you do, right, I want you to work hard, but also just as important, work smart. All right, because what you're gonna see often is, work like this. So this is someone using the quadratic formula, and in my opinion, they're working too hard. Why do you say that? All right, so here's our checklist that I'm gonna make up and give to you. So number 1, make sure your quadratic is set equal to 0. So you want your quadratic on one side and you want it equal to 0 on the other. So first step, okay, we're good. The second step is, notice all these coefficients, I could divide them all by 2. So you always want to divide by the greatest common factor. So just think about, why am I doing that? What's about to happen to all those numbers except the 0, right? What you're gonna see is that all those coefficients are gonna be cut in half. So when you're plugging it into the quadratic formula, right, the work is gonna be much easier because the numbers are gonna be much smaller. All right, so in my opinion, it's just gonna make life a lot easier. All right, so now what we're gonna do is we're gonna go in here and we're gonna look at our A. We're gonna find A, B, and C. And those are just the coefficients, the numbers in front, right, of our variables or our constant here. So A, the number in front of x squared, there's a 1, right, it's a visible 1. Number in front of x is -4. Make sure you got that sign right. And then the constant here is -12. All right, so next you're gonna identify your A, your B, and your C value. And what that's gonna do is we're gonna plug these values into our quadratic equation. And this, you just gotta be careful with your order of operations. So let's go ahead and do that. So you get X equals the opposite of B, and notice I'm putting that negative in parentheses so you don't forget it, plus or minus, because we're probably gonna end up with two answers, B squared, so we get negative 4 squared minus 4 times A times C. And everything, make sure that line, our division line, is under everything here, divided by 2 times A, 2 times 1. And now all we do is simplify. All right, so we get positive 4, right, because of negative and negative, plus or minus the square root. We end up with 16 plus 48. All right, and let me show you. Here we have 4, negative 4 squared is 16, and you have a negative and negative, that's why it's a plus, and then 4 times 12 is a 48. All right, so again, just be careful with all your signs here, and we're dividing that by 2. And some of you already take a sneak peek and like, hey, that's nothing like what we had earlier. Well, because our numbers are much smaller, which is good news. All right, so let's go ahead, simplify this more. So we get 4 plus or minus the square root, 16 plus 48, that's gonna leave us with 64, which is perfect because I know the square root of 64 divided by 2. And we'll look at another example at what happens when this is not a perfect square. And it's not too hard, it just takes more resources, right? We need to make sure we understand how to reduce radicals. And again, we'll look at that. Square root of 64, that's 8, and divided by 2. So this is where you're gonna have two answers, because one of the things we're gonna be left with is 4 plus, one of our solutions is gonna be 4 plus 8 divided by 2. So that's 12 over 2, which is 6, and that's what we got over here as well. And then we're also looking at the subtraction. So we're looking at the 4 minus 8 divided by 2. So we're left with negative 4 divided by 2, which gives us that negative 2 that we wanted. So there's our 2x intercepts. So there we have our 2x intercepts, right? Our two solutions. So what that means, if I plug in 6 back into the original function, right, the original equation here, if I plug in 6 there and 6 here and I evaluate this, that means that this side is going to be equal to 0, and you're going to end up with 0 equals 0, and it checks out. Or you could do the same thing with the negative 2, right? It'll also satisfy this equation. If we're looking at the graph, these are going to represent our x-intercepts. All right, so there is our first example. And again, look how small these numbers are compared to these. So you could see if we're dealing with some bigger numbers, man, this is going to save us a lot of time. All right, let's do another example. You ready? All right, so when we look at this quadratic, what you're gonna notice is, hopefully you're gonna notice, is it's not equal to 0. So let's make sure we do that first. So let's go ahead and subtract 3 from both sides. So you're gonna get 2x squared plus 5x minus 3 equals 0. All right, so first step, make sure our quadratic is set equal to 0. Second thing we're gonna do, see if you could reduce it. So see if you could divide every single term by a common number, by the GCF. In this case, there is no GCF. So right away we get down to work. So label your A, your B, and your C. So in this case, our A is 2, our B is 5, and our C is negative 3. All right, this next step is the most important. Make sure you smash that like button, and if you haven't done so, subscribe. All right, so let's write down the quadratic formula. And people are always saying, do I have to write it down every time? And what I tell them is you keep writing it down until you have this bad boy memorized, right? Once you have it memorized, then don't worry about writing it down. But until then, you write it down every time, all right? Or learn the song. All right, so let's plug everything in. So we get negative 5 plus or minus, right? And we're solving for x here. So we get negative 5 plus or minus the square root of b squared of 5 squared minus 4 times a times c, right? And everything is divided by 2 times a. So let's go ahead and simplify this. So we get negative 5 plus or minus the square root of 25, right? Because 5 squared. And then notice what we have here. We got negative and a negative, so that's why I have a positive here. And we have 8 times 3, which is 24. And then we're dividing that by 4 because we got the 2 times 2 on the bottom. All right, so simplifying this further, we get negative 5 plus or minus the square root of 49, which is excellent because I know the square root of 49, right? That's gonna leave us with 7. So we end up with negative 5 plus or minus 7 divided by 4. And so this gives us, this is gonna lead us to our 2 solutions. So one of our solutions is going to be negative 5 plus 7 divided by 4. So we end up with 2 fourths, which is 1/2. So there's one of our x-intercepts, one of our solutions. And then we're going to have negative 5 minus 7 divided by 4. So we're going to end up with negative 12 divided by 4, which is going to end up with negative 3. So there are our 2 solutions. And sometimes they want you to write it in set notation like this when you're writing your solutions. All right, so there you have it. Any questions? All right, so now let's look at one where it doesn't break down nicely. All right, but the good thing about this one is it's already set equal to 0. And I can't divide by a GCF, a greatest common factor. Right, there's no number they have in common. So right away, I'm going to label my A is 2, my B is negative 14, and my C is negative 13. And once again, I'm going to have my quadratic formula off to the side, and I have it every single time, right, until you have it memorized. I can't stress that enough. All right, another pro tip is that if these are fractions, what I would do is I would multiply everything by the least common denominator to get rid of the fractions, so you don't have to enter any fractions in here. So for example, if this were divided by 3, this were divided by 3, and this were just negative 13, I'll multiply everything by 3 to get rid of those fractions. So make sure you write that down because I'm sure you're gonna run across something like that. All right. So we are left with negative 14, so we're just left with positive 14 plus or minus the square root of negative 14 squared minus 4 times A times C. Oh, that's ugly 13. Divided by 2 times A. All right, so go ahead and get out your calculators and let's go ahead and simplify everything. So we're gonna get 14 plus or minus the square root of 14 squared is 196. And then we're gonna get plus 4 times 2 is 8. 8 times 13 is 104. And then we're gonna divide that by 4. All right. So again, you just want to make sure you double check your work and make sure everything's coming out nice here. No mistakes, because again, if you make one little mistake on the sign or anything and everything's gone, all your hard work is gone. So make sure you're very careful. And we got 196 plus 104, that's going to give us 300 divided by 4. And so here we can't simplify 300 and it doesn't come out to an integer, a nice number, right? We're gonna end up with a decimal. So instead of having the decimal, you can write it as a decimal. I'm gonna just reduce it as much as possible. I'm gonna simplify the radical, right? And we'll have a video link down below in terms of how to simplify radicals, just in case you need help with that. So we have 14 plus or minus. Since we have the square root of 300, we don't know the square root of 300. So what we do is we're gonna break it up. And the first number that we use to break it up, the first factor, has to be a perfect square. And that means I need to know the square root of that number. So for 300, what we're gonna do is we're gonna do 100 times 3. And the reason I'm using 100 is I know the square root of 100, okay? So this first number has to be the largest perfect square that fits inside 300. And again, watch that video, link down below if you want more practice on that. So the square root of 100, that is gonna give us the 10. So we end up with 10 square root of 3 over 4. All right, and if you haven't simplified these types of expressions, then what I want you to do is think about factoring. Can I reduce this in any way? So what I want you to do is look at your numerator here, your numerator. So you have 14 and 10. What's the largest number you could factor out? Well, it's 2. So I'm gonna factor out a 2, and what that's gonna leave me with is that's gonna leave me with 7 plus or minus 5 square root of 3. So basically I'm asking you, what's the biggest number you could divide into 14 and 10? But it has to fit inside both of them, right? So I factored out the 2. And remember, if you were to distribute, it better give you back what you started with, okay? And in our denominator, that 4, I'm gonna turn into 2 times 2, just so that we could see these 2's right here will cancel. So our final answer, we could just leave it like this. We could leave it as 7 plus 5 square root of 3 divided by 2, or, right, that's one answer, and our other answer is 7 minus 5 square root of 3 over 2. So these represent our 2 solutions, right? These were not as nice as the last one. And again, what this means is if I plug this into my calculator, it's gonna give me a decimal. And that's okay, because again, in real life, you don't always have these nice numbers. So again, this is something we should expect. So just a heads up, what does it mean if you had no x-intercepts? Well, what that would mean is that this number that's inside the radical would be negative. All right, so we would have, say, negative 300. And that would give you an imaginary number, which means you don't have any x-intercepts, all right? Or what if you had one x-intercept? Well, what would happen is that the number you're left with inside of the square root would be 0, all right? So if you want to see more examples, you let us know and we got your back. All right, mathletes, we hope you're having a great day. We'll see you next time. Peace. All right, mathletes, thanks for watching. And again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.